Supervised learning is an extremely important category in the field of machine learning. So with the help of supervised learning, we can perform both regression as well as classification. And in this course especially, we are going to look at tree-based models. So in tree-based models, we'll have decision trees as well as random forests. And with these tree-based models, as I've told you, we'll be performing both classification as well as regression.
Before we get started, I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments. Tree-based models are extremely important in the field of supervised learning. What makes these tree-based models so special is they can be used for both classification and regression. And understanding that, this course will cover tree-based models extensively. So we'll first understand what exactly are decision trees, and then we will have a demo on decision trees using Python. Then we'll understand what is bagging. Going ahead, we'll also learn about this algorithm known as random forest. And finally, we'll have a comprehensive demo where we'll do a bit of exploratory data analysis and then finally implement a random forest algorithm. So we'll start off with this algorithm called as decision tree. So decision tree is a supervised learning algorithm which is used for both classification and regression. And in this particular video, we'll be mostly focusing on the classification part of decision tree. So as the name states, a decision tree algorithm looks like a tree. And we have a very simple example over here. So let's say if you ask your friend whether your friend wants to watch the movie Avengers or not. So here what we are essentially trying to do is classify the problem statement. So the problem statement is whether you would like to watch the movie Avengers or no. So it's a yes or no question, and we will reach to the conclusion on the basis of certain decisions. So we have our first criteria over here. So you will start off by asking your friend whether he likes Marvel movies or not. So if your friend likes Marvel movies, if he says yes, then you will reach to the next stage and you will ask him the next question. Now you will ask your friend if he is a fan of Robert Downey Jr. And if your friend says yes, then he will most probably watch the movie Avengers. So here we are reaching this conclusion on the basis of these decisions. So if your friend likes Marvel movies and your friend also likes Robert Downey Jr., then he will watch the movie Avengers. Now, on the other hand, if your friend likes Marvel movies, but he's not a fan of Robert Downey Jr., then he will not watch the movie Avengers. But over here, let's say, at the first stage itself, your friend tells you that he is not a fan of Marvel movies. If he says no to this, then you will ask him if he's a DC fanboy. And if he says yes, then he will definitely not watch Avengers. On the other hand, if he says that he is not a DC fanboy, then you go ahead and you ask him if he likes Scarlett Johansson. And if he says yes, then he will watch the movie Avengers. On the other hand, if he says that he is also not a fan of Scarlett Johansson, then he will not watch the movie Avengers. So we are reaching this final stage over here. The final stage is where the classification happens, and we reach the final stage on the basis of certain decisions. And this entire algorithm, you have this tree-like structure, and that is why we call this as a decision tree algorithm. Now that this is clear, let's actually understand about this algorithm in general. So we have this algorithm called as CART. So CART stands for classification and regression trees. So CART, C is for classification, A is for and, R is for regression, T is for trees. So classification and regression trees. Now, as I've told you, with the help of a decision tree, you can perform both classification as well as regression. And over the course of the previous sessions, you would have learned that if we are performing any sort of classification, then our dependent variable needs to be categorical in nature. On the other hand, if you are performing regression, then your dependent variable needs to be numerical in nature. So we've got this example over here. So let's say we are just trying to say something is good or bad. So here you have two categories, and that is why we call this as a categorical dependent variable. So on the basis of x1 and x2, we are trying to classify whether this could be a product or this could be a service, and we are trying to classify whether this is good or bad. So we have some examples of classification problems. Let's say if we would want to classify whether the mail which you get is spam or not spam. So over here, you will have a dependent variable called as spam, and you will have yes or no over here. If you have a yes, then that would mean that the mail is spam. If it is a no, then that would mean that the mail is not spam. And on the basis of certain independent variables over here, so either you can have only two independent variables or you can have multiple independent variables. So on the basis of all of these independent variables, we are trying to classify whether this is a spam mail or not. Going ahead, we can perform a similar classification to find out if the patient has tumor or not. So again, here you have two categories, whether this patient has tumor or whether this person does not have tumor. And again, on the basis of certain independent variables. So the independent variables, you could have something like the blood pressure, the hemoglobin levels, or multiple other factors. And on the basis of those multiple factors, you are trying to classify whether this person has a tumor. Going ahead, we have another example. So let's say if you are working in a banking institution and a person comes up to you and asks for a loan. So here you would have to decide the eligibility of this person, whether you can lend him money or deny. So what you'll do is you'll have again multiple factors over here, and on the basis of all of the past transactions which this person has done, you will either lend money to him or you will deny. So these are some examples of classification which we can implement with this decision tree algorithm. And since with the help of decision tree, you can also perform regression methods. So when it comes to regression, your dependent variable needs to be numerical in nature. So here you see that x1 and x2 are numerical, but your y is also numerical in nature. And you have all of these different problems which you can solve. So let's say if you'd want to predict the stock return. So over here, the stock return will be a numerical value. Then you have predicting sports scores. So let's say if you're watching cricket and you would want to predict how much will a team score in 20 overs, then that is something you can do with the help of decision tree regression algorithm. Similarly, let's say if you'd want to set a price for a house or a price for a car, that is also something which you can implement with decision tree regression algorithm. So now that this is clear, let's actually understand how our decision trees built. So as it is stated, the general idea is that we will segment the space into a number of simple regions. So here we've considered all of these to be data points. So you have these different data points over here, and some of the data points are colored blue and some of the data points are colored red. So here this is a simple binary classification problem. So we are trying to classify either this data point is blue or this data point is red. But how do we actually build a decision tree classifier for this purpose? So what we do is we divide this entire space into different regions. So what we'll do is we will start off by drawing a line like this. And when we draw a line like this, you will see that we have divided this initial region into two sub-regions. And if you look at this, you will see that the upper region is predominantly blue colored and the lower region is predominantly red colored. Now again, I can subdivide this. So here I will draw another line like this, and you would see that in the lower half on the left side it is predominantly red colored and the right side it is predominantly blue colored. Again, I will go ahead and I can draw another line like this. And here you would see that on the left side it is predominantly blue colored and on the right side it is predominantly red colored. So we have initial data, and that initial data we are dividing into sub-regions. And now, how is decision tree involved over here? So the decision tree algorithm uses the same approach. So let's say we have a root node, and from this root node, what we'll do is, so first we are checking if x2 is less than 0.4. So let me go back over here. So initially we had this, and what we are checking is if the value of x2 is less than 0.4. Then we draw a line like this. Now going ahead, we again check if x1 is less than 0.8. So first we draw a line like this where x2 we are checking if it is less than 0.4. Then we are checking if x1 is less than 0.8 and we draw a line like this. And if the answer is yes to both of these cases, then we will classify it as red. And that is what we are doing over here. So on the other hand, if it is a yes to this and a no to this, so x2 is less than 0.4, but x1 is greater than 0.8, then we will classify it as blue. Then going ahead, if I look at this part over here, so initially at the root node, if x2 is greater than 0.4, so here as you see, if the value of x2 is greater than 0.4, then we are again checking the value of x1. Now we are checking if x1 is less than or greater than 0.4. And as you see over here, if x1 is less than 0.4, then we classify it as blue. And if x1 is greater than 0.4, then we classify it as red. So this is how the decision tree algorithm is built. So now all of this is clear, but how do we decide which node to split? So you would have, so right now in our data, we have only two data points. But when we have multiple independent variables, how do you decide which independent variable to split first? So this is where you have something known as impurities in your data. Now, what exactly is an impurity? So let's say if I consider the same data set over here, and let's say if there are 50% blue data points and 50% red data points. Now, if I call this entire data to be blue, what do you think is the misclassification error over here? So if I take this entire data set and I label it as blue, and since there are 50% blue points and 50% red points, I will be incorrectly labeling the rest of the 50% points. So here your misclassification error is 50%, and that is why the impurity which is present in your data will again be 50%. So this is what is known as impurity. And as it is stated over here, these metrics measure how similar a region or a node is. So here we have all of these different regions over here, and we are trying to understand how impure is this region. So let's say I have this, Now, if I label it as blue, what is the misclassification error over here? Similarly, if I label it as red, what is the misclassification error over here? And all of these things can be identified with some measures of impurity. And again, as it is stated, larger these impurity metrics, the larger the dissimilarity of the nodes or regions, which essentially means that if the impurity metric of, let's say, this particular region is high, then it would mean that there are the classification which you've given or the tag which you've given is mostly inaccurate. And we have different types of impurity metrics. We have Gini impurity, entropy, and variance. And for this particular class, we will be focusing on this impurity metric called as Gini impurity. Now we'll head on to the demo part, where we'll be implementing the decision tree classifier on top of the iris dataset. So before we actually build the model, let's actually go ahead and import the required libraries and the required dataset. So to work with this data frame, we would require a library called as pandas. So I will start off by importing the library. I will write down import pandas as PD. I'll hit on run. So we have successfully imported this library called as pandas. And this pandas library is one of the most widely used libraries in Python, and it helps us with data wrangling and data manipulation. And this also helps us in working with data frames. So if you don't exactly know what a data frame is, you can just consider that it is analogous to a table. So if you have worked with SQL or Excel, you would understand what a table is. So in simple terms, a table is a two-dimensional entity which has rows and columns. And if you'd want to work with tables in Python, you would have to convert those tables into a data frame. And for that purpose, we would need this library called as pandas. So we have successfully imported this library. Now, with the help of this library, we can read CSV files. So what is a CSV file? CSV stands for comma separated values. So whatever Excel files you have, either they have the extension of .excel or .csv. So it is again essentially your 2D entity with rows and columns, which has the extension of .csv. And to read a CSV file, we would need the pandas library. So I will write down pd.read_csv, and inside this I will give in the name of the file. And since I would want to work with the iris data frame, I have this file called as iris.csv, and I will go ahead and store it in this object called as iris. So I have also loaded the required library. Now I will go ahead and have a glance at the first few records of this data frame. And by default, if I would want to have a glance at the first 5 records of any data frame, I can use the head method. And here I will write down iris.head. And as you see, these are the columns which I have. I have sepal length, sepal width, petal width, and species. So I have 5 columns in total. And this also has 150 records. So this iris data frame is one of the most commonly used data sets in machine learning. And over here, we have 3 different species of the iris flower. We will have the Setosa species, versicolor species, and the virginica species. And as you guys know, when it comes to decision trees, it is used for both classification and regression. And in this demo, we'll be performing classification. And for classification, it is important for a dependent variable to be categorical in nature. And that is why here the species column would be our dependent variable and the other columns would be our independent variables. So what we'll do is, before we actually start off by implementing the model, we will do a bit of exploratory data analysis where we'll find some interesting observation from this data frame. So let's say if I would want to look at the distribution of this sepal length column, and if I would want to make a simple histogram for it, So for that purpose, I would need a library called as matplotlib, which is used for visualization. And this matplotlib library has a submodule called as pyplot, which I'll be using to create different geometries. So here I'll write down the command from matplotlib import pyplot as plt. I have loaded the required library. Here I've given the alias plt for pyplot. Then I'll just go ahead and make the plot. So first I'll assign the figure size. So there is this method called as figure. So I'll have plt.figure. Inside this I'll have the parameter fig size, with the help of which I can just set the dimensions of the figure which I'd want to make. And let's say I would want to set the dimensions to be equal to 5,7. Now, to make the histogram, the command is pretty simple. So all I have to do is write down plt.hist. And inside this, I will given, first I'll start off by giving the name of the data frame. Inside this, I'll given the name of the column. So here, the name of the column will be sepal length. So I'm creating a histogram with the help of this plt.hist method. Now, I'll hit on run. So this is what we have. Now, if I want to make it more aesthetically pleasing, so first I do not want this metadata. So if I do not want this metadata, I'll just write down plt.show and I hit on run. You see that all of that metadata has been removed. Now I would want to add a title and a X label to this plot. So I'll have this method called as plt.title, and inside that I'll just write down distribution of sepal length. Then I would want to set the X label. So here I will write down plt.xlabel, and here I will set the X label as sepal.length. So now, as you see, I have removed the metadata, I have added a title to this plot, and I have also assigned an X label to this plot. So let's try to get some inferences from this plot over here. So when it comes to sepal length, so as you see, we've got these three peaks over here. So it would seem that there are around 23 or 22 records whose sepal length would be somewhere between 4.5 to 5. Then again, we have more than 25 records where the sepal length is between 5.5 to be 5.8 or 5.9. Again, the similar case, we have around 25 odd records where the sepal length would be between 6.2 to 6.5. Now, if you go above this, you would see that as the sepal length increases, the number of records decrease. So you can say that on an average, the sepal length of all of these flowers would lie in the range of maybe 5 to around 6.5, and there are very few species of setosa flower, or there are very few records of iris flower where the sepal length is actually greater than 7. So if you go beyond 7 over here, you would see that there are very few records whose sepal length is actually greater than 7. So this is quite an interesting observation, isn't it? So this was with respect to sepal length. Now similarly, if I would want to understand the distribution of petal length, I can just go ahead and draw another histogram over here. So I'll follow the similar procedure. What I'll do is I will write down plt.figure, and inside this I have the parameter called as fig size. So I'll set down fig size over here, and I will set the figure size to be equal to 5,7. Then I will just go ahead and make a histogram. So here it will be plt.hist, and inside this I would have to make a histogram for petal length. So it will be iris, and inside this I'll give in the name of the column, which will be petal.length. Then I'll set a different color to the bins this time. So I'll set the color of the bins to be equal to green. So if I just given G over here, that would mean that this is of green color. Then I will write down plt.show to get the result without the metadata. And this is what we have. Now, after this, again, as we did with respect to the sepal length, if I would actually want to add the X label and the title, what I'd have to do over here is I need to add two more methods. So I'll just write down plt.title and I will set the title as distribution of this is petal length. Then I'll also set the X label over here. So this will be plt dot X label, and here I will set the X label as petal dot length. And this is the final result. So we have the title, distribution of petal length, and this is the X-axis label, which is petal length. And if you look at these particular bins over here, you would see that we have very contrasting bins over here. So there are more than 35 records where the petal length is between 1 to 2. So we have this particular peak. It's not even 1 to 2, it's only between 1 to 1.5. So more than 35 records where the petal length is between 1 to 1.5. Then again, you have a peak over here. So there would be around, let's say 27 or 28 records where the petal length would be somewhere between 4.5 to 5. So here you have one peak, here you have another peak. So this is quite interesting when it comes to the petal length. So this was some basic exploratory data analysis. Now we will go ahead and build our decision tree classifier on top of this data frame. And as I have told you, species column would be our dependent variable. And what we'll be doing is we will be using the sepal length column as our independent variable. So for this purpose, I would have to extract the target and the independent variable. So let me go ahead and do that. So let me just add a comment, machine learning starts now. And I will start off by extracting the target and the independent variable. So target, I'll go ahead and store in y. So it'll be y is equal to iris. And I would have to extract, what do I have to extract? I'd have to extract the species column because that would be our dependent variable. So species column is our dependent variable and that I'm storing in this variable called as x. Similarly, I would have to go ahead and extract the sepal length column. So sepal dot length, this I'm extracting. Let me keep it in small case. So this I'm extracting and putting it in this variable called as x. So we have these two variables over here ready. And after this, now once I have my dependent variable and the independent variable, the norm is to divide the data into training and testing sets. And why is that important? So let me give you guys a very simple analogy. So let's say you are appearing for an exam and someone, maybe your friend, comes up to you and tells you that the paper has been leaked. And let's say if there are 5 questions in the exam and all of those 5 questions have been leaked and your friend gives you that question paper. Now, if you actually go ahead and learn only those 5 questions, and if you go to the exam the next day, and if exactly those 5 questions come up, well, then you're in luck and you'll get 5 out of 5 and your accuracy is 100%. But what if maybe your friend got a fake question paper and none of those questions actually come up in the exam? So what happens is you prepared only 5 questions, but none of those 5 questions come up in the test. So what happens over here is you will get 0 out of 5 and your accuracy is 0. So that is why training is especially important before you actually go for the test. So you have to implement the same sort of philosophy with respect to machine learning as well. First, you'd have to train your model. Now, once you train your model, once your model learns all of the features associated with the training data, that is when you would have to go ahead and predict the values on top of the test data. And that is what we'll be doing now. So to divide the data into training and testing set, we will need this library called as sklearn. So from the sklearn package, we have this sub module called as model selection. So what I'll do is I will write down from sklearn dot model selection. I would have to import train, test, split. Again, let's just wait for this to load. Right, so we have imported this method called as train, test, split from the model selection submodule of sklearn package. And now we will go ahead and pass in the parameters inside this. So I'll have train, test, split, and this takes in the independent variable, dependent variable, and the test size. So independent variable is present in X, the dependent variable is present in Y. Now I'll have something called as a test size, and I will set the test size to be equal to 0.3. So what does this mean? Well, this means that 70% of the records go into the training set and 30% of the records go into the test set. Now this returns 4 objects. And what are those 4 objects? Let me just tell you. So we will have something called as xtrain. Then we will have something called as xtest. After that, we will have ytrain. And then we will have ytest. So what are these 4 variables? So xtrain is your training set for the independent variable. Xtest is the testing set for the independent variable. Ytrain is your training set for the dependent variable, and ytest is the testing set for your dependent variable. So this is something which you would have to remember. So we have these 4 objects being returned by train, test, split method. Now once that is done, since we have our training and testing sets ready, let's go ahead and import the decision tree classifier. So decision tree classifier is a part of the tree module. So here I will write down from sklearn.tree import decision tree classifier. So I have imported decision tree classifier from sklearn.tree. Now, since I have the decision tree classifier, I'd have to create an instance out of this. So I would just have to write down decision tree classifier, and this I would have to store in this object called as DTC. So this is just an instance, and this is just a simple name which I'm giving to this instance for this decision tree classifier. So now that we actually have the instance ready, with the help of this instance, I can fit the model on top of the training set. So I'll have dtc.fit, and I will be fitting this model on top of the training set. So the training set will be xtrain and ytrain, and I'll hit on run. And we have successfully built this model. And as you see, the split criteria over here used as Gini index. So we have built the decision tree. Now it's time to predict the values. And to predict the values, I will have something called as dtc.predict. And I would have to predict the values on top of the test set. So it will be x underscore test. And I will store the result in ypred. So ypred will have the predicted values. Let me just show you what is actually there in ypred. So when I run ypred, you will have these predicted values on top of the test set. So now I would want to see how many of these values are actually correctly predicted. And for that purpose, we have something called as a confusion matrix. So let me actually first import confusion matrix, and then let me tell you what it is. So confusion matrix is a part of metrics. So I'll write down from sklearn.metrics import confusion underscore metrics. So now that we have imported confusion metrics, what I'd have to do is I'd have to use this method. So I'll write down confusion underscore metrics, and inside this I would have to pass in the actual values and the predicted values. So our actual values are present in y_test, which is the testing set for the dependent variable, and these are the predicted values which are present in y_pred. So actual values and predicted values. Now what exactly is this? So here, consider these on your rows to be the actual values and on your columns to be the predicted values. So your left diagonal will be all of those values which are correctly predicted. Now let's say if we have setosa over here. So let's say if we have setosa, versicolor and virginica. Then again we will have setosa, versicolor and virginica. So this would mean that out of the 14 records of setosa, 13 have been correctly classified as setosa, 1 has been incorrectly classified as versicolor. Then after that, we have this record for versicolor. So here you have 8 plus 4, 12, plus 12 plus 3, 15. So of the 15 records for versicolor, 8 have been correctly classified as versicolor, 4 have been incorrectly classified as setosa, and 3 have been incorrectly classified as virginica. Then again, similarly for virginica over here, so out of those, so you have 7 plus 7 plus 2, which is 16. So of the 16 records for virginica, 7 have been correctly classified as virginica, 7 have been incorrectly classified as versicolor, and 2 have been incorrectly classified as setosa. So now if I would want to find out the accuracy in prediction, the left diagonal indicates all of the correctly predicted values. So if I divide the left diagonal with all of the other values, that will give me the accuracy. So what I would have to do over here is, it will be 13 plus 8 plus 7 divided by, so now I will have 13 plus 8 plus 7 plus 1 plus 4 plus 3 plus 7 plus 2. Let me change it to 2 over here. So here when I hit on run, you would see that we get only an accuracy of 62%, which is not really great. So it seems that if we use only sepal length as our independent variable, and if we would want to try to predict the class of the species, then the accuracy which we get is not actually much. So now what we'll do is we'll do something interesting. So instead of using sepal length, maybe we use a combination of something else. Maybe we actually go ahead with sepal length and petal length, and let's see how that actually goes. So this time what we'll be doing is, so what I'll do is maybe I'll, well, let's actually work in the same notebook. So I will write down model 2 over here, and when it comes to model 2, again, I would need to extract my dependent variable and the independent variable. So dependent variable obviously would be stored in y. So here I have y is equal to iris. Inside this, I will have the species column. So species column again is my dependent variable. Now I'll be doing something different over here. So here for the independent variables, so first I will have sepal length. So let me write down sepal dot length over here. Then I will also have petal length as my independent variable. So this time what I'm doing is multivariate classification, where I have more than one independent variable. So here sepal length and petal length are two of my independent variables, and on the basis of this we are trying to predict the species of the iris flower. So we have dependent and independent variables ready. Now again, it's time to do the same stuff. So we'd have to import train test split. So I'll have from sklearn dot, so this will be model selection. Let me write down model selection. I will import train test split, and inside this I'll pass in the independent variable, the dependent variable, and after that I need to set a test size. So I will have test size, and let's say this time I set the test size to be equal to 0.4, which would mean that 40% of the records would be in the test set and the rest of the 60% of the records would be in the training set. So we seem to have an invalid syntax over here. Let's see what exactly is that. So here we have from sklearn.model selection import train test split. Let me actually see what is the error over here. Right, so here when we are actually importing it, I do not have to write any of this, so I'll remove that. And also I would not require this. So now that I have actually imported this, then I can go ahead and use train test split. So I'll write down train test split. Inside this I'll give in X and Y, and after this I will give in the test size. So I will have the test size to be equal to 0.4, which as I've told you would mean that 40% of the records would go into the test set and the rest of the 60% of the records would go into the training set. And this would return 4 objects. The first object is obviously xtrain. The second object is obviously xtest. So now that we have xtrain and xtest, then we would need ytrain and ytest. So this is ytrain, then we have ytest. So what is xtrain? It is the training set for your independent variable. What is xtest? That is the testing set for your independent variable. Then you have ytrain and ytest. And what are these? Ytrain is the training set for your dependent variable and ytest is your testing set for the dependent variable. So I have divided the data into training and testing sets. Now again, I would require the decision tree classifier. So from sklearn.tree import decision tree classifier. Let me write the spelling properly over here. And after this, let me create a new instance of this and let me call this DTC2. So DTC2 would be equal to decision tree classifier. I'll hit on run. So we have an instance for decision tree classifier as well. Then going ahead, what I'd have to do is I'd have to fit the model. So it will be DTC2.fit, and obviously I'll be fitting this on top of xtrain and ytrain. So I have fit the model. Again, the split criterion is Gini index over here. Now I would have to predict the values, and to predict the values it will be dc2.predict, and inside this I would have to predict this on top of the test set. So this I will go ahead and store in ypred2. So I have my actual values and the predicted values. Actual values would be stored in obviously ytest, and the predicted values would be stored in ypred2. And to find out the accuracy, I need to use the confusion metric. So let me write down confusion metrics over here. And the first parameter would be the actual values which are present in ytest. And the second parameter is ypred2. So let me write down ypred2, which has the predicted values. And this time, as you see, when I have included a combination of sepal length and petal length, the classification seems to be much better. So here, out of the 15 records of setosa, all of the 15 records seem to be correctly classified as setosa. Then for Virginica, out of the 21 records for, this is actually versicolor, so out of the 21 records of versicolor, 19 of them have been correctly classified as versicolor and 3 of them have been incorrectly classified as virginica. Then out of the 23 records for virginica, 21 have been correctly classified and 2 have been misclassified. So to get the accuracy of this, I'd have to divide again the left diagonal with all of the values. So this time it will be 15 plus 19 plus 21 divided by 15 plus 19 plus 21 plus 3 plus 2. And now when I hit on run, you would see that we get an accuracy of 93%. So the difference in accuracy is extremely clear and visible for you folks. So when we only use sepal length as our independent variable, we get an accuracy of only 62%. But when we use sepal length and petal length as our independent variables, we get an accuracy of 93%. So this is a huge jump in the accuracy of the model. And this brings us to the end of the demo. Now we will head on to the next tree-based classifier, which is a random forest. So there would be some scenarios where your decision tree fails to give you proper accuracy. So as it is stated over here, decision trees are very sensitive to even small changes in data. And that is why these decision trees are very unstable and these are known as weak classifiers. So if we would want to work with strong classifiers, what we can do is club these bunch of decision trees together and we will get a random forest. So again, as the name states, random forest. So what is a forest? A forest is a collection of trees, isn't it? So when you combine multiple decision trees together, you will get a random forest. Now, if we take the same example of Avengers, you go to your friend and you ask your friend if you should watch the movie Avengers. Now, let's say he has a very biased opinion and he hates all of the Avengers movies and he hates all of the Marvel movies. So, even though if the movie is good, because of his biased opinion, your friend will tell you that Avengers is a not good movie and you should not watch it. But on the other hand, instead of asking just one friend, let's say if you go to 10 of your friends and ask your 10 friends, then out of these 10 friends, 7 might tell you to watch the movie and 3 might tell you to not watch the movie. So on the whole, out of these 10 people, 7 believe that Avengers is a good movie and you need to watch it. So this is how a random forest works. So you aggregate the result of all of these decision trees. And again, since a random forest is just an extension of a decision tree, it can be used for both regression and classification purpose. So if we are using the random forest algorithm for the purpose of regression, then we can just take the mean of the final result of all of these individual decision trees. And on the other hand, if it is a classification problem, then in that particular case, we can take the mode of all of the results. So this is how we can work with a random forest. So let's understand the underlying concept of random forest. So before understanding random forest, we need to understand the concept about bagging. So bagging is known as an ensemble algorithm. And what exactly is an ensemble algorithm? In an ensemble algorithm, you combine multiple weak classifiers together to make a strong classifier. So what happens when you're applying a decision tree is, let's say you have this data set D1 and you will apply this decision tree algorithm on top of this and you will get one result. But what if I want to get a collective result? So what I'll do is I will clone this data set. And when I say clone, we are actually performing sampling with replacement. So what I'll do is from this data set D1, I'll create multiple data sets. So if this data set D1, let's just say has 100 records in it. Now what I'll do is I will create another data set D2 from these records, but I'll be taking those records randomly. Now, when I say randomly, I can take the same record twice, or I can also miss out on some records which are present over here. So this is sampling with replacement. So let's say if I take record number 3 from this, put over here, and then again I will keep it back. So the second record can also be record number 3 from this. Third record also can be record number 3 from this. And then I can take record number 100 from this. So this is totally random. And this is how I will create dataset 2. Again, I will create another dataset 3, which will be sampling by replacement. So like this, I can have a collection of data sets. So this is known as bootstrapping. So bootstrapping is you are creating multiple data sets from your original data set by using sampling with replacement. Now, let's say if we create 100 data sets out of our original data set. So initially we had only, let's say 100 records in this one data frame. Now we have 100 into 100 records. So that gives us a better chance of prediction. And from all of these data sets, what I'll do is I will create or I will build one individual decision tree algorithm on each of these data sets. So I will be building 100 decision trees, and each of these decision tree will give me a result. And if it is a regression algorithm, then I can just take the mean of the final result. And if it is a classification algorithm, I can take the mode of the final result. So this is how bagging works. But what is a random forest? So random forest is again an extension of bagging. So in random forest, you need to focus on the term random. So why is it called random? Because the split criteria which you are using over here. So normally, whenever you are splitting the node, you are splitting it on the basis of your independent variables. And when it comes to bagging, you will have all of your independent variables available for the split. But when it comes to random forest algorithm, you will get only a select set of random independent variables. So let's say if this data frame has 10 independent variables, in case of bagging, all of the 10 independent variables would be available for the selection criteria. But when it comes to random forest, you will only get a random subset of all of the columns. So from the 10 independent columns, you might only get 3 random columns. So what happens is, every time you build a decision tree, the split criteria used will be different. And this is how the decision trees which you build will also be different. So since here 3 random variables are used, here again 3 random variables are used, here again 3 random variables are used. So this is how your decision trees would be completely different from each other. And now when you're actually getting the final result, this would be better than your normal bagging algorithm. So this is what happens in bagging and random forest.
So now we'll go ahead and implement a demo on random forest in Python. So this will be a comprehensive demo where first we'll start off by doing exploratory data analysis on top of the COVID-19 data set. Then we will go ahead and implement the random forest algorithm. So first we would have to import all of the required libraries. So I'll just go ahead and do that. So we would need the pandas library for data manipulation. Then we would need matplotlib, which is for visualization. So I'll write down from matplotlib import pyplot as plt. Then we will also need seaborn, which is another visualization library built on top of matplotlib. So here we would need, I'll write down import seaborn as SNS. Then in our current data set, we have certain dates in it. And by convention, the dates which are there, they would be present as categorical labels and not as a date column. So we would also require the date time library. So let me import that as well. So here I'll write down import date time as dt, and I would also require the numpy library. Import numpy as np. I'll hit run, and let's just wait for all of these libraries to load. Now, in the meanwhile, these libraries are loading. I would have to load up the required file. So the file is in CSV format, and to read the CSV files, we have the read_CSV method, which is part of the pandas library. So while these libraries are loading, I'll just write the next command over here, which will be pd.read_CSV. And inside this, I need to give in the name of the file. So the name of the file is COVID-19 India.csv. And as I've said, there's a date column over here. So I will write down parse dates is equal to, and here inside parenthesis, I'll write down date. Then I'll add another parameter where I'm just setting the day first to be equal to true. So I'll write down day first is equal to true. This I will go ahead and store in an object called as df. Let me do this right over here. Now I'll have a glance at the first few records of this data frame. So to have a glance at the first few records of a data frame, I need to use the head method. So this will be df.head. And as you see, we have all of these columns. S number, which is just the index number of this particular record. Then we have this current date. So as you see, this is 30th of January 2020, 31st of January 2020, 1st of February 2020, and so on. Then you have the time over here, state or union territory. Then you have confirmed Indian national. Then you have confirmed foreign national, cured, deaths, and confirmed. So these are all of the different columns which are present. Now, out of all of these columns, I would need only certain columns, which would be the date column. So I would not require the time column. I would not require the S number column. I would require state, union territory. I would not require this. I would not require this. Then I'll also take cured, deaths, and confirmed. So what I'll do is I'd have to extract all of these columns. Let me go ahead and do that. So here first I need to give in df, and inside parenthesis, what I'll do is I would have to give in all of the columns which I'd want. So I would need date, I would need state, union territory. Let me write down properly over here. So it is state / union territory. Then I would also need the cured column. After this, I have the deaths column. Then I have the confirmed column. So I have extracted all of this, and I will go ahead and store in this object called as df. So it's just that this is the original data frame. From the original data frame, I'm extracting only these columns, and I'm storing it back to the original data frame over here. Now I'll again hit on run. So we seem to have an error over here. So I need to give in proper indexing. So we have date, state, union territory, cured, deaths, and confirmed. So state, union territory, we seem to have a problem over here. Let's just actually see if I've given the, so there shouldn't be a space over here. Now let me hit run. Right. Now I will have df.head again. And as you see from the original data frame, I have only extracted date, state, union territory, cured, deaths, and confirmed. Now again over here, so state and union territory. So this is the column name over here is very big, and I would want to rename this. So again, what I'd want to do is so you have capitals over here. So it's better if I have the starting letter of all of these columns small. So I'll also change them to be small. And it's instead of having state / union territory, I'll just have the column name as state. So let me go ahead and do that. So for this purpose, what I'll do is I have this columns method. So I'll just write down df.columns, and inside the list, I will give in the new names. So first I'll have date, then I will have state. After that, I will have cured, then I will have deaths, and then I will have confirmed. I'll again hit on run. Now let me again show you the first few records of this df.head, and as you see, I have renamed these columns. Now after this is done, so as you see, these are all of the columns which I have, and the date, as you see, it starts from 30th of January 2020. Now if I actually show you the tail, that will give me the final date. So this would be in ascending order. So when I have df.tail, so here you would see that we have all of this data till 17th of July 2020. So starting from 30th of January. So this is the first record which we have for Kerala. So in Kerala, there was the first confirmed case was found on 30th of January 2020. And as you see over here, so as of 17th of July 2020, in West Bengal, there have been 36,117 cases. Similarly, in Uttar Pradesh, there have been 43,441 cases. So this is quite interesting over here. Now, what I want to do is, I would want to extract all of the cases which have been there till today, or in other words, I would want to extract only the date. So here, as you see, this is the current date, or this is the latest date, which is 17th of July. So I would want to extract all of those records where the date is equal to 17th of July. So let's see how can we do that. So again, this is our original data frame, which is df. So from this, what I'd have to do is df.date, because this is the column. So df.date needs to be equal to 2020-07-17, and this I will go ahead and store in an object called as today. I'll hit on run. Now I will have today.head, and let's see what do we get. So as you see over here, so I have all of the cases with respect to different states as of 17th of July 2020. So as of 17th of July 2020, there have been 180 confirmed cases in Andaman and Nicobar Islands. Similarly, there have been 38,000 cases in Andhra Pradesh, 543 cases in Arunachal Pradesh, 19,000 cases in Assam, 21,000 cases in Bihar. So this is something interesting, isn't it? And now after this, what I'd want to do is I would want to sort this with respect to the number of confirmed cases. So as you see, I would want to know which state has the maximum number of confirmed cases. So since this is a numerical column has this method called as sort values. So what I'll do over here is I will write down today dot sort values, and inside this I would have to sort this data frame with the help of the confirmed column. So I'm basically sorting this data frame by the confirmed column, and this has to be in descending order. So I will set ascending is equal to false. So I'll basically have that particular state which has the maximum number of confirmed cases at the top. And this I will go ahead and store in an object called as max confirmed cases. So let me write this down properly over here. And then I will have a glance at the head of this. So it will be max confirmed cases dot head. And as you see, so as of 17th July 2020, Maharashtra has the maximum number of confirmed cases. So Maharashtra has 284,281 confirmed cases as of 17th July. Then followed by Tamil Nadu. So in Tamil Nadu, you have 15 1,56,000 confirmed cases. Then in Delhi, you have 1,18,645 confirmed cases. So you see that the difference between Delhi and Karnataka as of 17th July over here, it's almost 50,000. As 17th July, there have been 1 lakh cases in Delhi and 50,000 cases in Karnataka. And similarly, if you see the difference between these three, so between Maharashtra and Tamil Nadu, there is a whopping difference of 1,30,000 cases as of 17th July 2020. So again, an interesting analysis which we have directly found out by looking at this data set. Now, what I'd want to do is, so as you see over here, I have only the top 5 records. Now, I would want to make a simple bar plot for this. So to make a bar plot, I would need the first 5 records. So what I'll do is, I will only take the first 5 records out of this. So I will have, let me take this, let me paste it over here, and I would need the first 5 records, and this I will go ahead and store in an object called as top states confirmed. Let me put a hyphen over here. Now let me print out top states confirmed. Let me write this down properly over here. And as you see, we've got the top 5 states. Now, what I basically want is, I would want to make a bar plot, which means that I would want the state column on the x-axis and the confirmed values on the y-axis. And for this purpose, I would need this library called as Seaborn, which we have already imported. So for this, first I'll go ahead and set the figure size, or maybe we can do that later. So what I'll do is, I will directly write down sns.barplot. So this is how we'll be creating a bar plot. And on the x-axis, what I'd need is, I would need the state column, and then I would need something on the y-axis. So on the y-axis, I would need the confirmed column. And where are these 2 columns coming from? These 2 columns are coming from top states confirmed. So data is equal to top states confirmed. Then let me just hit on run, and I'll have plt.show over here. Let me just write down plt.show so that all of this metadata is not there. And as you see, we have this simple bar plot over here, which tells us the maximum number of confirmed cases as of 17th July 2020. So this tells you clearly that Maharashtra has the maximum number of confirmed cases. Then you have Tamil Nadu, then you have Delhi, then you have Karnataka, then you have Gujarat. So this is quite interesting over here. Then, as I've told you, let's say if I would want to change the figure size. So I have the set method inside the Seaborn library. So I'll just write down sns.set. I have this parameter called as rc, and I will set the figure size inside this. So here I will have figure.fig size, and so this I'm basically giving as a, this I'd actually have to give as a dictionary. So let me put this inside a dictionary and not inside a list. So I have figure.fig size. This is the key, and the values would be, I would just have to give in the dimensions of the image. So let's say if I set it as 15,10, now if I hit on run, so you'd see that the dimensions have changed. Let's say instead of 15,10, if I only keep it to be 5,5 and then hit on run, you would see that again the dimensions of this plot have changed. So this is quite interesting over here. Then going ahead, what I'd want to do is, so this was the maximum number of confirmed cases. Now similarly, I would want to find out the maximum number of deaths. So to get the maximum number of deaths, I would have to just take the same command as you see over here. And instead of sorting this with respect to confirmed, I would have to sort the data frame with respect to deaths. So let me change the by to be deaths, and this I will go ahead and store in an object called as max death cases. And once I've stored it inside this, let me have a glance at the head of it. So I'll have max death cases dot head. So here again, it seems that the most number of deaths have been in Maharashtra as of 17 July 2020. Then you have in Delhi, you have 3,545. In Tamil Nadu, you have 2,236. Gujarat, you have 2,089. Uttar Pradesh, you have 1,000 deaths. So quite interesting over here. Now, if I'd have to make a same plot out of this, like we have made a bar plot above, so what I'd have to do is I would have to extract the top five records again out of this data frame. So let me take in the same command over here. And instead of max confirmed cases, this time it will be max death cases. And this I will store in an object called as top states death. So now that we have this ready, again, I would have to make the plot for this. So again, making the plot as similar, we just have to use the same command over here. So as you see, sns.set, with the help of this, we are setting the figure size. Then we have sns.barplot. On the x-axis, it will be state. And on the y-axis, instead of confirmed, it will be deaths. And data is coming from top states death. So let me change this to top states death and plt.show. That is how we are just showing this out. So this has to be top states death and not deaths. And this is our result over here. So as you clearly see, most number of deaths in Maharashtra. So let me actually compare this particular plot with this plot. So this tells you the most number of confirmed cases, and this tells you the most number of deaths. So the most number of confirmed cases are in Maharashtra, and also the most number of deaths are in Maharashtra. But if you look at the confirmed cases and deaths of other states, so you see that UP is not among the most number of confirmed cases, but over here, as you see, UP is listed at number 5 when it comes to the most number of deaths. So this is quite interesting over here. So again, Delhi, which was at the 3rd place for most number of confirmed cases, but when it comes to deaths, it is at the 2nd place. And again, if you talk about Karnataka over here, even though Karnataka has the 4th number of confirmed cases as of 17th July, but you see that Karnataka is not listed among the top 5 states where most number of deaths have happened. So all of this was basic data visualization, which we have done. Now, similarly, I would want to do the same stuff for states where we have most number of cured cases. So for this purpose, I would have to again sort my data frame. So I will take this particular command over here. I will paste it over here. And this time what I would have to do is, so it will be today.sort values, and instead of deaths, it will be with respect to the cured column. And then I will go ahead and store this in an object called as max cured cases. And let me just have a glance at this. Max cured cases dot head. And when I hit on run, you would see that these are all of the columns which I have. So most number of confirmed cases were in Maharashtra, and also most number of cured cases are in Maharashtra. Then you have Tamil Nadu, Delhi, Gujarat, and Telangana. So you see that when it comes to Telangana, this is quite interesting. Even though it wasn't listed as one of the states as most number of confirmed cases or most number of deaths, but it seems that people who've been confirmed in Telangana, they've been cured more in Telangana. So quite an interesting analysis over here. Then going ahead, what I'd want to do is make a similar plot out of this. So to make a plot out of this, what I'd have to do is first take the top 5 records. So this time I would, so this will be max cured cases instead of max death cases. And I would need the top 5 records. And I will store this in an object called as top states cured. Now I would have to just create the same plot for this as well. I will take this command, I will paste it over here, and this time the data is coming from top states cured, and on the x-axis I will have the state column. It's just that on the y-axis I will have the cured column, and when I hit on run, you would see that this is how the plot looks. So again, a very pretty and informative plot which we have made over here. Now going ahead, what I'd want to do is I'd want to analyze individual states. So till now we have understood that Maharashtra has had the most number of cases and most number of deaths as well over there. So that's it. That is why I would want to understand what exactly is the trend when it comes to the state of Maharashtra. So what I would want to do is from the original data frame, df.state is equal to Maharashtra. So I would want to extract all of the records from the original data frame where state is equal to Maharashtra. And I will go ahead and store this in an object called as Maha. Then I'll just show you the head of this, maha.head. So as you see, it seems that the first case in Maharashtra was on 9th of March. So on 9th of March, there were 2 confirmed cases. Then I will have maha.tail over here. And when I have maha.tail, you would see that as of 17th July, there have been 284,281 cases. So from 9th March to 17th of July, from 2 cases, the number of confirmed cases have gone to 284,281. So this is extremely interesting over here. So now what I'd want to do is how I'd want to understand how have the number of confirmed cases increased from 9th of March to 17th of July over here. So for this, I would want to make a line plot where the date column will be on the x-axis and the confirmed cases will be on the y-axis. So for this, I would have to create a line plot. So I'll write down sns.lineplot, and on the x-axis, since I would need the date column, I'll just put in date over here. And on the y-axis, I will need the number of confirmed cases. So here I'll write down confirmed. Then going ahead, I'll give in the state. So here the state will be equal to Maharashtra. Then I'll just give a color to the line. So here the color will be equal to green. And then I would just have to print this out. So it will be plt.show. So seems like we have an error over here. Let's actually understand. String object has no attribute get. So why do we have this? So let me give in green over here. Let me give in an entire color and let's see if this works properly. So seems like we again have the same error over here. X is equal to date, Y is equal to confirmed. So this has to be data is coming from Maharashtra, color is green. So all of this seems to be fine. So what I'll do is I'll actually copy paste the same command from above. That will be easier. So let me copy this and let me paste it over here. And instead of having this as a bar plot, I will keep it to be line plot. And here on the x-axis, I would need the date column. On the y-axis, let's actually see what do we need. On the y-axis, we would need the confirmed column. And the data is coming from the Maharashtra, which we have just created. So let me change this to Maharashtra over here. And here, let me actually change these dimensions. So I'll increase the width of this. So instead of keeping it 5, I'll keep it 10. And as you see, maybe I'll increase it even more. I'll keep it 15 over here. That might be better, I guess. So as you see, the growth of number of confirmed cases has been exponential. So from the date over here, if you look at this, this is 22nd of March 2020 and this is 22nd of July 2020. So from being from 0 confirmed cases, so from March to July, as you see, the growth of number of confirmed cases is quite exponential. And maybe during this particular time, so maybe from 22nd of March 2020 till over here, so till this is 1st of May 2020, there were not many cases. So during the first 2 months, there were not many cases. But then again, from 1st of May, the number of cases have grown exponentially. So this seems to be something interesting. So something during 1st of May, during that particular week, might have happened in the state of Maharashtra, and this would have led to the increase in number of confirmed cases. Now, what I'd want to do is I would want to make a similar line plot for the number of deaths as well. And here the command will be same, sns.set, and on the y-axis I'll be mapping deaths instead of confirmed. And as you see, this is the trend over here. So again, you have the date from 22nd of March going on till 22nd of May. So again, till 1st of May, you do not have a lot of deaths. But from 1st of May, this grows exponentially. And this particular line which you see, so this maybe, so you have June. So this might be the end of June over here. So maybe somewhere between 25th of June, you would see that the spike over here is it's enormous over here. So being from 2000, it almost, so being from 4000, it almost spiked up to 6000 over here. So till then, the growth was not so much high, but during this particular span, maybe in a span of just 2 to 3 days, the number of deaths have grown exponentially. And after this, again, as you see, the trend just keeps on increasing with respect to number of deaths over here. So this is with respect to Maharashtra. Now I would want to do a similar analysis for the state of Kerala as well. So here, what I will do is, again, I would have to extract all of the records from the original data frame, where the value in the state column is equal to Kerala. So df, and here I need to give in the name of the column. So here inside df, I need to set df dot state is equal to Kerala. And this I will go ahead and store in an object called as Kerala. Then let me just have a glance at this. So Kerala dot head, and if I run this, so here you would see that the first case in Kerala was reported on 30th of January. So you have one confirmed case. Now similarly, let me see what was the final number of confirmed cases. So Kerala dot head, I'd have to actually change this to tail and not head over here. And when I run this, here you would see that the number of confirmed cases as of 17th July, they are 10,275. And this is quite contradicting when compared to Maharashtra, isn't it? So when you look at the table of Maharashtra, you would see that the first case was confirmed on 9th of March. And from 9th of March to July, the number of confirmed cases is exponential. It's staggering. But when you look at this in the state of Kerala, so the first confirmed case was on 30th of January itself, which was 2 months before the first confirmed case in Maharashtra. But you see the total number of confirmed cases as of 17th July 2020, you would see that they are very low. The growth of the confirmed cases has been very, very less in Kerala when compared to Maharashtra. So this might tell you something interesting. So there might have been certain situations in Maharashtra because of which there has been this sudden explosion of number of cases. Now, what I'd want to do is I would want to make similar plots for the state of Kerala as well. So let me copy this same command over here, and I would want to make a line plot where I would want to see the growth of the confirmed cases. And here the data is coming from Kerala and not the Maharashtra state. So line plot on the x-axis, I'll have the date column. On the y-axis, I'll have the number of confirmed cases. And here, as you see, so the growth again over here. So this is starting from February of 2020 till, if maybe we can say, again, this would be end of May or the starting of June, you don't have a lot of cases. So it's only from starting of June that the number of cases have started to spike up in Kerala as well. And similarly, I would want to have a look at the number of deaths in the state of Kerala as well. I'll copy the same command, I'll paste it over here, and on the y-axis, instead of confirmed, I will have the deaths column. And this time, if you see, this is quite interesting over here. So from February till maybe February, March, April, you do not have a lot of deaths, or maybe you don't have any deaths at all. And in the month of April, maybe you will have around 2 to 3 deaths, and that is not very gradual. But then again, as you see, from the end of May and the starting of June, the number of deaths have again spiked up. So this is again quite an interesting analysis which we have done over here. Now going ahead, what I'd actually want to do is I would want to build a random forest algorithm which will actually tell me how to predict the number of deaths. So that is something interesting. So here I'll be actually using random forest regressor. So I'll be using the random forest algorithm as a regression algorithm and not as a classification algorithm. And I would want to see I would want to predict the number of confirmed cases if I given a date. So let's say if I given the next date, so here we have dates till 17th of July. So let's say if I would want to predict the number of confirmed cases on 18th of July, I would want to do that with the help of this random forest classifier. And this is where the main part comes in. So let's go ahead and start doing that. And we'll be implementing this on top of the Maharashtra data frame which we have. So for that purpose, first we would have to import all of the required libraries. So here I would need the train test split method from model selection. So I will start off by writing from sk learn dot model selection import train test split, and I'll hit on run. And this is important because we would have to divide our data into training and testing sets before we actually build our model. And why is that important? Let me just give you guys a simple example. So let's say if you're appearing for a test and it is the situation is such that, let's say your friend comes up with you and tells you that the paper has been leaked, and there will be 5 questions in the exam, and he tells you what those 5 questions are. Now, if you prepare only those 5 questions and go to the exam, and if exactly those 5 questions come up, well, you're set. You will get 5 out of 5. But what would happen if, let's say, none of those 5 questions actually come in the exam? Now, since your training has only been with respect to these 5 questions, if anything comes out of syllabus, then obviously you will not be able to answer. You will get 0 out of 5. So this is why training and testing is important. So first you would have to train yourself, then you would have to test yourself how much you have learned. And we will have the same concept when we will be using machine learning algorithms as well. So first you would have to train your model on top of the data, and only when the training is done, that is when you will go ahead and build the model on top of the test data. So that is why we would need this train test split to divide our data into training and testing sets. Now what I'd have to do is I would so as you see, now again, if I have to build a random forest regression algorithm, so here, since this is regression analysis, my independent variable, it cannot be categorical in nature and it cannot be date. So I would actually have to convert this into an ordinal value. So as you see this, we cannot have a date over here, and to use the dates in a random forest classifier, I'd actually have to convert this into an ordinal value. So ordinal value, it's just that would mean a number. So each date will have one particular number over there. So what I'll do right now is I will convert the date column into an ordinal value. So as you remember earlier during the starting of this demo, we had imported the date time library. So let's go ahead and convert this. So from the Maharashtra data frame, we have the date column. I have the map method, and inside the map method, what I'd have to do is dt dot date time, and I would have to convert this into ordinal. So dt dot date time, so again dt is the date time library. So from the date time library, I'd have to convert this into ordinal. What do I have to convert? I'd have to convert the date column into ordinal values, and this I will actually go ahead and store back into the same column. So this will be Maharashtra date. Let me hit run now. Now what I'll do is I will have a glance at my data set. So I'll have maha.head over here. And when I hit on run, so you would see that all of the date values, they have been converted into ordinal values. So initially we had dates like these, but now with the help of this, we have converted them into ordinal. So we have one specific number for each of the date value. Here, since I would have to predict the number of confirmed cases with respect to date, this will be my independent variable and this will be my dependent variable. Now, let me go ahead and extract my dependent and independent variables first. So I will store my independent variable in x. So it will be x is equal to maha. Inside this, I'll need to pass in the date column. Then I would also need to extract the confirmed column, which will be stored in the y object. So here I will have confirmed. So I have extracted x and y. Now, since I have my independent and dependent variables, I can finally use the train test split method to divide my data into training and testing sets. So here I will write down train test split. Inside this, I will pass in x, y, then I have another parameter called as test size. So test size, let's say if I given a value such as 0.3, This would mean that 30% of the records would be in the test set and rest of the 70% records would be in the training set. And then this method will give me 4 outputs. So let's see what those are. I will have something called as xtrain, then I'll have xtest. After that, I will have ytrain, then I will have ytest. So here xtrain means that it is the training set of independent variable. Xtest is the testing set of independent variable. Ytrain is training set of dependent variable and ytest is testing set of dependent variable. So we have all of the independent variables and dependent variables with respect to train and test sets ready. Now once we have this, I would have to go ahead and build the model. So to build the model, I would need random forest regressor. Let me go ahead and import that. So I'll write down sklearn dot ensemble import random forest regressor. And here you'd have to keep in mind that R, F and R are capital over here. So R in random is capital, F in forest is capital, and also R in regressor is capital. So from sklearn.ensemble import random forest regressor, then I'd have to create an instance of this. I will call this instance as, let's say, RF. So I'll have RF is equal to random forest regressor. And once I create this, I would have to build this on top of the training set. But now I will actually show you how the training set looks like. So ytrain, what is ytrain? Ytrain is the training set of the dependent variable. And here, what is our dependent variable? Dependent variable is the number of confirmed cases. And here you see that I have all of these index values. So I do not want this index values corresponding to also my actual values over here. So I just want to remove these indices. So if I don't want to remove these indices, I would need the help of NumPy library, which I have imported earlier on. So here, what I'll do is, while fitting this, I'll just write down dtr.fit. Inside this, I will have np.array. And what I'll do over here is, inside the array, I will pass in xtrain and I would have to reshape this. So I will have reshape. So xtrain, ytrain, they have the indices as well, and I do not want this indices. So I'll have dot reshape -1, 1. So when I give in -1, 1, this will remove the indices. And then similarly, I will have np dot array. Let me keep this properly. np dot array. Inside this, I will have ytrain dot reshape, and again I would have to give in -1, 1 over here. So this dtr.fit. So we are building or fitting the model on top of the training set. So training set is basically xtrain and ytrain. But our xtrain and ytrain have these indices, and we have to reshape these training sets without the indices. So that is why I'm using this particular command. And let me hit run. So this is actually RF and not DTR. Let me change this to be equal to RF. And we have successfully built our random forest model. So now that we have built our model, what I'd want to do is I would want to predict the values. So I will have maha.tail. Let me run this. So as you see, so with respect to a particular date, I have a confirmed value over here. Now let's say if I would have to predict something, what I would want to do is I will have rf.predict, and so when we have to predict something, it will give you the result of your dependent variable. And what do we have to pass in? We would have to pass in the independent variable. So independent variable is your date, And here, this value which you see, 737623, this gives you your date. Now let's say if I give something such as 737600, and if I hit on run, there actually seems to be a problem over here. So here I would actually have to pass this as a numpy array. So inside this, I will have np.array, and I will have, let's say if I given 737600, I hit run. So seems like I'm making some error over here. So this actually has to be written in this particular format. So it'll be rf.predict np.array. And let's say if I want to predict something, maybe, so this is 737623. So now if I want to know how many cases were there 23 days back, I'll give in a value of 600. And this gives us a value of, as you see, there were 1,39,950. Maybe if I change this to, let's say, 450. Again, if I hit on run, so you would see that this gives you a value of 7.7. So this might not be exactly accurate. So this is a very baseline random forest model which we've built. And also, let's say if I would want to change this. So let's say if I keep this as 737 and I keep it to be, let's say 737650. And if I hit on run, so this gives you a value of 275298, which is actually less than the value of the number of confirmed cases as of 17th July. So this is quite interesting, isn't it? So again, this is a very baseline model, and this baseline model will give you inaccurate results. So this brings us to the end of this session on where we have done a proper exploratory data analysis on top of the COVID-19 dataset. Then we learned how to implement the random forest regression algorithm on top of it.
This brings us to the end of this course. Thank you very much and have a great learning ahead. I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.